All right. So before we begin, myself and Ravi, we predominantly focus on service mesh technologies, being Consul. So we're just going to talk a little bit and share about, at a high level, what Consul is. Not going to dive into a lot of the specific use cases. We're going to focus mainly on service mesh and observability and tracing today. But I think it's good for those that aren't aware some of the other capabilities. So, those that aren't familiar, Consul is a service networking platform that can help discover and securely connect any service across any runtime, right? So we support multi-cloud environments, Kubernetes, virtual machines, and we help, securely connect them through authentication authorization or MTLS. We encrypt the traffic, and we help them connect to other services, along with other capabilities like load balancing, traffic management, your splitting scenarios, and so forth, right? So at a high level, there's some of the capabilities. I won't go through too much more, but if there's any questions that you want to dive into about Consul, you can go to consul.io. You can reach out to myself, Ravi, or Eric, and we can, of course, spend further time and talk about some of the other capabilities, right? But again, today we're going to focus around service mesh predominantly. And again, service mesh, some of the common use cases why our customers, adopt service mesh, and why the general kind of industry, are looking at service mesh and so forth. That solve challenges around service discovery, whether that's across multiple kube clusters, VM to kubes, vice versa, or across different clouds. They're one of the reasons. Same with traffic management. How can I do things like canary, AB, blue, green, and so forth as well? How can I shift traffic from one service to another service without any interruption? Security is obviously, a big talking point today, and that's another reason that service mesh is being used, again, to encrypt service communication, service to service as well. And, for the most part, again, to, observability, right? So by layering service mesh or having service mesh enabled in your environmental platform, you gain increased observability through telemetry, through additional logging, but also for today's discussion, you also gain the ability to do tracing. So one of the well-known drivers, and we're going to just take a step back here, and I think for most of us, we're going to know this already, or we've probably heard what I'm going to talk about next in a lot, plenty of times before, right? But one of the well-known drivers for adopting a service mesh platform is due to the shift from monolithics to microservices and the associated complexities with that. And although they bring great benefits, there is definitely challenges that we see around service communication, right? Now we're going to assume everyone's familiar with what a monolithic is, and also microservices and distributed architectures. But just in case, just to kind of set the scene here, a monolithic is in a way what we call traditional, or somewhat legacy in a way. Not always the case, but it's generally a group of services that are contained together, right? It's tightly coupled. When you debug typically the entire monolithic, right? When you deploy it as one. It's typically associated with legacy code, right? Pretty straightforward. Again, microservices, this is generally well understood now. But when we look at microservices architecture, it's loosely coupled, right? Which gives us these benefits that, you can scale services more easily. Typically, they deploy independently, which means you can iterate independently, so forth as well, right? But the primary culprit for problems when it relates to microservices architecture is service connectivity. It's becoming a lot more difficult to identify root cause, especially if you compare to monolithics, right? So, this is a fairly, there's about 5-6 services illustrated here, right? And for the most part, it's not as complex. But if you start to think about, hundreds to thousands of microservices to tens of thousands, right? It becomes increasingly difficult to quickly identify and troubleshoot those issues, right? So we're going to look at using trace tools to allow us to visualize these services to better understand their relationships, right? And the goal here is to make investigation easier and to pinpoint issues quicker, right? So when you implement a service mesh, it enables users kind of to extract additional data, right? Again, I spoke about enhanced observability, telemetry, and so forth. You can actually extract layer 7 data from applications and feed that into your monitoring solutions. That gives you greater visibility into the problem areas. It helps eliminate issues before they become more widespread. However, having visibility into issues is just the beginning. When you add distributed tracing to services running in a service mesh, you actually get a lot more fine-grained details about connection requests, successes, things like retries, timeouts, where failures are occurring, as they move through the data plane, right? So because we're talking about observability, I thought it would be good to kind of share a few things about the folks who know about running microservices or distributed architectures at scale. And this quote is from the Google SRE team. So, from a user-facing system, if you can only measure 4 metrics, you want to focus on these 4, and they call them the 4 golden signals. So latency, and that's something we're going to look at today. The time it takes to service a request, this influences things like user experience as well. So it's important to distinguish between the latency of successful requests and the latency of failed requests and so forth. And there are different triggers. We won't go into too much depth about, this given the time. But at a high level, we'll cover some of these and we'll get to visualize some of these. Traffic, it's a measure of how much demand is being placed on your systems. For a web service, this kind of measurement is usually like HTTP requests per second, something like that. Errors, it's good to look at errors as well, the rate of requests that fail. So when we think about APIs, when we think about layer 7, things like HTTP 500s, and saturation as well, how full is your service, right? So it's a measure of your system's, kind of fractation, emphasizing on the resources that are most constrained. So if it's an in-memory constrained system, you look at memory, right? Show memory. If it's IO constrained, like a database, you look at IO and so forth, right? So these are the key measures that are fairly important to look for to ensuring that the users, from an external point of view, that the system is behaving somewhat good. Obviously, there's a whole ton of other metrics. These are the 4 golden ones that Google consider. And if you go to that source there, you'll get a good white paper on this topic. So with that in mind, with latency in mind, and with errors in mind, so forth, we're going to look at distributed tracing now. And we're going to, and I'm going to explore some of the basics today. This is a much more complex topic than we certainly have time today to discuss at length, right? So, but fundamentally, distributed tracing enables users to track a service's request as they progress through and allow developers to obtain a visualization of that flow. We're going to be using Jaeger today. There's a whole bunch of other tools as well, and we've publicly done some webinars with Datadog and so forth as well. At a high level, this is done by adding traces to an application or service. So that's the important bit. We need to add a trace ID. That's where it starts, right? A trace is like a unique request ID that can be used to identify that request across all microservices involved. So these traces then collect key metadata, record things like timing about the operation by that specific store, and they store it as a span. So there's 2 elements. There's a trace and span that we'll have a look at today, right? Again, a trace represents that data or execution path through that system. As an example, a trace is like a collection or list of spans connected to a parent relationship or child-parent relationship, right? So once a span is being created, it then gets ingested and aggregated by a tracing platform like Jaeger that we'll show today. A span represents a logical unit of work that has an operational name and a start time and a duration. So for example, a span is like a HTTP request to a service, a call to a database or something like that. Now, again, if we go back to that microservices architecture that I spoke about before, and we think about this scenario, this is like kind of like a nightmare scenario, right? And these are extreme examples, but they're real examples. There's one thing that is certain, right? Complexities will increase with microservices or distributed architectures. There's no doubt about that. It will become increasingly difficult to troubleshoot using traditional methods. So by adding tracing capabilities, you enable your development, your application teams to get much more granularity into what is causing failures, and obviously, rectify them sooner, or in a way, rectify them before they become actual problems or before they impact users. So for example, let's keep it simple. Let's say service A is failing to connect to service B. If we only know that service A and service B are unable to communicate, we have to go step by step to see where the error is starting. So this is kind of, if we know they're failing, traditionally, if it's a monolithic, there might be a few number of connections, right? So it's quite simple, right? Or easier, I would say, to troubleshoot, right? But with microservices, this can be much more complex because it could flow through a number of APIs, right? It's commonly known if you hit like a website today, it's driven by an API backend. Even though you're seeing the same interface, you could be hitting up to 20 APIs, right? And they could be dependent on each other and so forth. So they could span across different clouds and different platforms. So searching for connection errors manually can really impair some of those benefits that microservices offer and make it really difficult, right? But if you start to add tracing, we can start to visualize that flow and actually identify almost exactly where service A stopped talking to service B, right? Making it easier to fix. So let's dive into this quickly and have a look at one of the applications I'm going to show you today. And you might have seen this before. It's called HashiCups, and this is the topology I have. So myself as a user, I'm going to load up the UI interface, but there's a few components of HashiCups. There's a GraphQL component or an API, which is my public API, my front-end pieces. Then I have two components, which are key to the app. There's a product API, which displays all of the products being coffee, and has a Postgres backend. And then I have a payment service where when I actually put something in the cart and I actually make a transaction, I go pay for my coffee, that invokes that service. But the GraphQL, the product API and the payments API is what we're going to look at today. And, they're probably API driven. And we're going to have a little, visualization around some errors and so forth. So with my payment service, I actually have two versions, and I'll show you this in a bit. I have one version which is operating completely fine as I expect it without any issues. I have version 2, which I injected some failures into. So I'm actually running Chaos Monkey in there, and I've injected some latency into version 2 of payments. And I'm actually running, because I'm running service mesh, I'm actually running some traffic management capability where I'm splitting my traffic. So from my public or my GraphQL, I'm actually splitting the traffic 50-50 between the good version and the chaos version, right? Just to show you what good looks like and where the bad looks like so that we can identify where that failure happened. But I am using some splitting, some traffic management capability. So we should see good requests, bad requests, good requests, bad requests, and so forth, right? So let me walk you through that now. I've already deployed this. They're running, this is running on Kubernetes, specifically EKS, running Consul service mesh, so everything is secure as well. But let's focus on some of the observability pieces. So. Okay, so I'm hoping everyone can see my screen.
Yep, we're seeing your browser screen now. Yeah.
Thanks, Eric. So we're seeing Consul at the moment. I am running the service across different namespaces as well. Quickly show you that the services are online. This is the front end piece. That's the payments. That's the products piece. Again, just to quickly show you, the payments has 2 versions. So these, the number of instances, they're pods essentially. I'm running a replica of 2 for each. The version 1, which again is the good service, and I have the KL service, which is version 2. Again, I'm running to both of those services, so it's 50-50 at the moment. This is the front end. Again, so right now, let me just do some things. Let me just quickly create some transactions. So I'm just going to add that checkout. I'll put on some details and fill it in. That's an error. Okay. Sometimes that's expected because that could have went to the bad service. We'll quickly add some more and pay now. Okay, that's a little bit better now. We're not getting any errors. So you could see that, you know, potentially I have a 50-50. So usually what's happening here is if we had more time, I would show the website and the traces interacting with a good flow where all traffic is going to version 1 and healthy. And then as I iterate and make changes, I want to slowly shift to version 2. But as I shift, I want to see if there's any issues or errors to make sure that I've, you know, rectified any code problems or anything like that, or anything with the service, right? Before I fully cut over to that new service, right? But in the interest of time, I was just showing 50-50, and you could see that one was good, one was bad. So this is Jaeger. This is my, you know, the Jaeger is an open source tracing visualization tool. Obviously, there's other enterprise tools out there as well. We won't discuss that today. But you know, Consul has integration and a large ecosystem. Please reach out if you want to discuss that a little bit more. I'm just going to go find these traces, and you can see here that this is the trace, and I'm looking at the payment service. I'm looking at the pay, but we'll see. Okay, so each one of these is a trace, and then we'll go in and we can see the spans. But let's have a good one first. So this is a good one now. So let's go into that. And this is what a trace looks like. And again, you see the start time. That was roughly when I initiated that first one. You can see the duration is about 24 milliseconds. It's gone through, and these are spans. The first one being that's when it started, and then it's gone through the Envoy proxy. It's hit the payments downstream. So if you click into them, you can get information around some of the process, the endpoints, and so forth. If I go to payments, I can see the downstream service. Again, I'm tracking. I can track the flow of where it's going. I can see the duration of that as well. I can see the component here. This is the actual pay component. When I actually hit pay, I can see that took 4.2 milliseconds. I can see that the component with the Java web servlet and so forth, 200. So there's a few things I can see here. I can see particularly some of the outputs around the pre-handles and the after completions and so forth, right? And that all looks good, right? From a timing perspective, from a just a flow perspective, no issues really, right? And it processed the card. I can actually see the details here as well. Usually when it's a credit card payment, this will be encrypted, right? But again, you know, this is a good flow, right? And if I go back, it completed in about 24 milliseconds. I actually have a bad flow here, right? That took a bit of, you know, I was doing this a little bit before. Again, if I hit more, I'll see some more bad flows, but this one took a bit longer, right? And it's a big difference in time. So from 24, 25, that's pretty good. But I'm now seeing, you know, up to 250 milliseconds of latency, right? And the great thing here is you can see, you know, some of these hits up here, right? You quickly identify, and if you start to see a lot more, obviously, circles up here, then you got wider problems, right? But let's go back to this 250 milliseconds. You know, this service call and hold took a long time. I can see here that the public API, I can see it flowing through here. I see it flowing through the components, right? But as you start to expand, and I'll quickly expand these out, you can start to see where things have gone wrong. And if I quickly look at the logs, and obviously the timing's building up, that, you know, this one, the pay service here, or the pay component, that's about, at least the pre-handle is about 54 milliseconds. But if I look at this, I can quickly tell there's some issues here at the after completion. So I would say, you know, from a development team, application team point of view, I can quickly identify through tracing where the actual component service call that is actually causing the issue. And I'll be, hey, why don't you have a look at this after completion events and focus your efforts there, because everything through the flow, every other call, every other connection is fine. But I can actually see very fine grain where the problem potentially will lie, right? So that's one of the benefits of tracing, right? Especially, and the depth of this it's only 2 services, right? It's from public to payments. But again, if you have, it's not uncommon to see depths of cores of 10, 20 upwards, right? Being identify these issues quickly, it's going to be of massive, massive benefit. There's other things we can do. Again, I won't go too much into functionality of Jaeger, but the goal here is to show you how to quickly identify and some of the benefits of leveraging service mesh and distributed tracing, especially across distributed microservices environment. That's pretty much all we have time for today. But please reach out in the chat. We can have offline conversations about this. We do have documentation and tutorials on how to configure these, and they're fairly straightforward as well. Happy to share the Terraform code that I've used to deploy this environment, so you could have a poke around as well and test this for yourself, right? But yeah, I'll stop there for now.